Hello everyone, welcome to Jack tutorial. Today we are going to see the working of round robin scheduling algorithm. In round robin scheduling algorithm, every process is allowed to execute for a particular time period, and that time period is called as time slice. Time slice or TQ. Time slice or TQ. Now here the processes are executed in FCFS manner. However, preemption is added after end of every time slice. So here the number of processes given are 5. See, I'm writing here the processes along with its burst time. So number of processes are, let's say, P1, P2, P3, P4 and P5 along with the burst time are 5, 24, 16, 10 and 3. As per this algorithm, every process is allowed to execute for one time slice or one TQ. So in this case, for the case of round robin scheduling algorithm, the value of TQ here specified is 5 units or 5 ms, assuming that burst time is given is in ms. So now we have to draw the Gantt chart. So when we will start drawing the Gantt chart, we know that the process execution will be in FCFS order, that is first come first serve. So every process will be allowed to execute for 1 TQ. So at t equal to 0, process P1 will start to execute and it will execute for one time slice. The value of time slice is 5 unit. Burst time of process P1 is also 5. That means after first time slice only, the process P1 will complete the execution. So now process P1 has completely executed its execution and it has now terminated. Then at t equal to 5, process P2 will start and it will execute for again one time slice. So value of one time slice is 5. That means 24 minus 5, remaining time is 19. So P2 will also execute for one time slice, that is 5. So it started at 5, executed for 5, that means 5 plus 5, 10. At t equal to 10, process P2 has completed its execution for one time slice, that is 5 units, and now remaining time is 19. Then process P3 is scheduled. Again it will execute for one time slice, process P3, and now its time burst time is 16. It has executed for 5 units, so remaining time will be 11. So process P3 has also executed for 5 units, so started at 10, so 10 plus 5, 15. Then next P4 will be scheduled. Its burst time is 10. It will again execute for one time slice. Its value is 5, so 10 minus 5, remaining time is 5. So P4 is executed for 5 units, so 15 plus 5 is 20. Now if we observe carefully the burst time of process P5, which is 3, which is less than one time slice. So here process P3 will leave the CPU. There is no need for any timer interrupt, because before the timer interrupt appears, the process is voluntarily releasing the CPU because its burst time is over. So process P5 is going to start at 20 and its burst time is 3, so it will complete its execution at t equal to 23. So its remaining time is 0. So 5 minus 5, remaining time is 0. That means now after first cycle, process P1 has completed its execution and process P2 has also completed its execution. That means they are now out of the main memory. Now ready queue has 3 processes, P2, P3 and P5, with remaining time as 19, 11 and 5. So in second cycle, process P2 will start. At what time process P2 will start? 23. It will execute for one TQ. TQ value is 5. So that means P2 will execute for one time slice, that is 5. So 23 plus 5 is 28. Now here remaining time will be 19 minus 5, that is 14 for process P2. Then process P3 will be scheduled, will be executed for one time slice, that is 5. So 11 minus 5, remaining time is 6. So here process P3 will start at 28, will execute for one time slice. So 28 plus 5, that is 33. And then process P4 will start. Remaining time of process P4 was 5, so 5 minus 1 time slice value, that is 5, is equal to 0. That means after end of the second cycle, process P4 will also complete the execution. So P4 will complete the execution at t equal to 38 after second cycle. That means now process P4 has also completed its execution, and now we have only 2 processes remaining in the ready queue with 14 and 6 burst times, remaining burst times. Okay, so now I am continuing the Gantt chart here. Okay, so now at what time we have stopped? 38. Okay, so that is what I am writing here again. So now at 38, process P2 will start again. So process P2 will start again. Its burst time is how much? Its burst time is, remaining time is 14. So 14 minus 5, remaining time will be 9. So it will start at 38. So 38 plus 5, it will become 43. Okay, and then process P3 will start. So 6 minus 5, remaining time will be 1. So process P3, 43 plus 5, it will become 48. So after this cycle, we have 9 and 3 remaining time of these 2 processes. Okay, so again then process P2 will start. Process P2, remaining time is 9. So 9 minus 5, its remaining time will become 4. Okay, so P2 will execute for 1 time slice. So 48 plus 1 is, it is 43. Okay, it is 43. And now process P3 will start. Process P3, remaining time is only 1. So 53 plus 1, that is 54. At 54, process P3 will execute for 1 unit, not 1 time slice, 1 unit, and its remaining time is 0. That means at t equal to 54, process P3 has also completely executed. And now finally only 1 process is remaining, that is process P2. P2 will start at 54 and will execute for 4 units. So P4, 54 plus 4, that is going to become 58. So at t equal to 58, all processes has completed their execution. All processes has completed their execution. So what we can observe here, every process is allowed to execute for 1 time slice or time quantum, and here processes are executed in first come first serve order. Only the preemption is added after end of the every time slice. So here what we need to calculate, we need to calculate the turnaround time of each process. So let's calculate turnaround time for process P1. Here arrival time of every process is considered as 0. Arrival time for every process is considered as 0. So that means every process is submitted at t equal to 0. So process P1 is submitted at t equal to 0 and process P1 is completed at t equal to 5. So turnaround time for process P1 is 5. Then for process P2, turnaround time, see here, submitted is as t equal to 0 and completed. See, P2 is completed where? P2 completion here at 58. So this is nothing but turnaround time for process P2. Then for process P3, see, submitted at 0 and P3 is completed where? At 54. So 54. Then for process P4, see, submitted at where? 0. Completed at where? P4, where it is completed? Here at 38. So 38. And finally process P5, submitted at 0, completed at where it is completed? Here at 23. So 23. This is nothing but turnaround time of these processes, 23. So average turnaround time is equal to addition of all these divided by total number of processes. Alright, so you can do the addition and you can divide number of processes. Alright, so number of processes are here 5. Let's do the addition. So here that addition comes to somewhat 178, that is divided by 5. So that answer is equal to 35.6 units or ms. Fine. Now let's calculate waiting time. So when we calculate waiting time, that waiting time is what? Turnaround time minus burst time. So let's calculate for process P1. What is turnaround time? That is 5. Burst time is 5. So 5 minus 5, that is equal to 0. Then for process P2, turnaround time is 58 minus its burst time is 24. So 58 minus 24, that is 34 for process P2. Then for process P3, it is 54, that is turnaround time, see here, and minus the burst time. So burst time for process P3 is 16, that comes around 38. Then for process P4, turnaround time is 38. So 38 minus 10 is the burst time, and that comes around 28. And finally for process P5, the turnaround time is 23 minus the burst time is 3, that comes around 20, waiting time 20. So here we have waiting time 0, 34 for P2, 38 for P3, 28 for P4, and for P5 it is 20. So average waiting time is equal to 0 plus 34 plus 38 plus 28 plus 20 divided by total number of processes, that is 5. It comes around 120 divided by 5. The answer is 24 ms or units. 24 ms or units. This is nothing but average waiting time for the given set of processes along with the burst time for scheduling algorithm, that is round robin. I hope this explanation has cleared your doubts about how round robin scheduling algorithm works. Thank you.